Alright, in this lesson we'll be talking on Fourier series over any range. Now let's take for instance we are given we have been using range of 0 less than x less than 2 pi or minus pi less than x less than pi or even 0 less than x less than pi. What if we are given numbers as our range? Let's take for instance we are given 0 less than x less than 1, or even maybe 0 less than x less than 2. It can also be minus 2 less than x less than 2, or even minus 4 less than x less than 4. Now these are characterized as over any range. It's not, it doesn't have a function of or it doesn't contain a multiple of pi. Okay, so with respect to that, these are the formulas we'll be using. So we can see that the f of x itself changed. Okay, it changed. It contained some different things in between it. That's 2 pi nx over L. So we are familiar with 2 pi, we are familiar with n, we are familiar with x. What we are not familiar with is L. What is L? Now let's take for instance we have minus 2 less than x less than 2. Now if we draw like a line diagram for it, we have minus 2, minus 1, 0, 1, and 2. Now the distance between the upper limit and the lower limit is known as L. Okay, so this one is 1, 2, 3, 4. So L is equals to 4. Okay, now let's take for instance we have minus 1 less than x less than 1. The distance between minus 1 to 0 to 1 is measured as our L, which is what? 2. Okay, or simply say that if we have minus a, or if we have a less than x less than b, then our L is equals to b minus a. So this is our b and this is our a. So L, which is b minus a, will be equals to 2 minus minus 2, and which is equals to 4. This is our b and this is our a. L, which is equals to b minus a, equals to 1 minus minus 1, which will be equals to 2. So these formulas in red are very important when solving Fourier series over any range. So as usual, we have to evaluate a naught, we evaluate an, we evaluate a bn. At the end, we slot them into the function f of x. So for this reason, we have a question to solve. It says find the Fourier series of the function minus 2x2, and we are given individual limits. Okay, now we can see the individual limits, but the first thing to do we must know is that we must know what is our L. What is our L? Now going further, we are moving from minus 4 less than x less than minus 2 and all through down to 4. Okay, so minus 4 all through down to 4. This is the entire limit. or range. So therefore our L will be equals to B minus A, and our 4 is B, and our minus 4 is A. So our L is what? 4 minus minus 4, which is equal to 8. Now, since we know our value of L to be equals to 8, then we can now evaluate A naught. Now, A naught from the formula is this, is 2 over L, 2 over L integral, 2 over L, 2 over L integral of minus L over 2 to L over 2 f of x dx. Now let's substitute our value for L. So we have it to be 2 over 8 integral minus L over 2 is minus 4, and L over 2, that's 8 over 2, is 4 f of x dx A naught. Now if we now take a close look at this, and we take a close look at the question in itself, it reminds us of discontinuous function. So we can say that this, okay, let's solve it. Moving it down, A naught is equals to 1 over 4 integral of minus 4 to 4 f of x dx. Now we can split it across board for individual range. So the first range is 1 over 4 integral of minus 4 to minus 2 f of x dx, minus 4 to minus 2. The next range is 1 over 4 integral of minus 2 to 2 f of x dx, minus 2 to 2 f of x dx, and 2 to 4. 1 over 4 from 2 to 4 f of x dx. Now with this done, we can now substitute the corresponding f of x for the corresponding limits. So we have minus 4 minus 2. The f of x for minus 4 to minus 2 is minus 2, followed by x, followed by 2. So we have it to be minus 2 dx plus 1 over 4 integral of minus 2 to 2 of x dx plus 1 over 4 integral of 2 to 4 of 2 dx. And now with this done, we can simplify it further and say that this will give us 1 over 4. Okay, minus 2 can cancel out 4, and we'll be left with 1 over minus 2, or minus 1 over 2, integral of minus 4x minus 2 dx plus 1 over 4 integral of x dx from minus 2 to 2. This can reduce this, and we're left with 1 over 2 integral of 2 to 4 dx. So this is just like integrating a constant. And leave it as 1, and also leave this as 1. So when we integrate the functions, we have x here, because integrating 1 will give us 1, or will give us x, and integrating x will give us x squared over 2 minus 2, and integrating 1 will give us x from 2 to 4. So next thing is to impute individual upper limits and lower limits. So we have 1 over minus 2 from minus 2 minus minus 4 plus 1 over 4 into 2 squared over 2 minus minus 2 squared over 2 plus 1 over 2 into 4 minus 2. So solving this on, we have 1 over minus 2. Minus 2 minus minus 4. That's minus 2 plus 4. And that will give us 2 plus 1 over 4. And this will give us 4 over 2 minus 4 over 2 plus 1 over 2 into 2. 4 over 2 minus 4 over 2 will give us 0. So the whole term there is cancelled out to give us 0. So this whole term nullifies to give 0. And we are left with 1 over minus 2 into 2 plus 1 over 2 into 2. And this will give us minus 1 plus 1, which is equal to 0. So in short, we're saying our A naught is equal to 0. Now the next thing to evaluate after evaluating A naught is to evaluate AN. And AN from the setup formula is 2 over L integral of minus L over 2 to L over 2 f of x cos 2 pi nx over L dx. Now we know that our L is equal to 8. Okay, we know that L is equal to 8. So then we replicate what we have there, substituting our L. So AN is equals to 2 over 8 integral from minus 4 to 4 f of x cos 2 pi nx over 8 dx. Now AN will be equals to 1 over 4 integral of minus 4 to 4 f of x cos pi nx over 4 dx. Now, provided we have these as our AN, and we remember from the question where f of x is equal to minus 2x and 2, this one ranging from minus 4 less than x to minus 2, minus 2 less than x to minus 2, plus 2 rather, and 2 less than x less than 4. So we can split minus 4 to 4 individually like we have done for A naught. So AN will be 1 over 4 integral of minus 4 to minus 2 f of x cos pi nx over 4 dx plus 1 over 4 integral of minus 2 of f of x cos pi nx over 4 dx, and finally plus 1 over 4 integral of 2 to 4 f of x cos pi nx over 4 dx. Moving forward, we can now substitute our values of fx for the corresponding limits. So an will be equals to 1 over 4 integral of minus 4 to minus 2. F of x for this range is minus 2 cos pi nx over 4 dx. 1 over 4 minus 2 to 2. F of x for this range is x cos pi nx over 4 dx plus 1 over 4 from 2 to 4. F of x for this range is 2 cos pi nx over 4 dx. So now, after I've done that, we can now proceed and solve an appropriately. So minus 2 can cancel out 4 here, and we have that an is 1 over minus 2 from minus 4 to minus 2 cos by nx over 4 dx, and this will give us 1 over 4 minus 2 to 2 of x cos by nx over 4 dx plus 1 over, left with 2, integral of 2 to 4 cos by nx over 4 dx. Now this can be integrated directly. This can also be integrated directly. However, this will be splitted into uv, and we know that u, when we integrate uv, we have it to be u v1 plus u prime v2 minus u prime v2 plus u prime prime v3, and it continues in that order. And we know our u is equals to x, and our v is equals to cos by nx over 4. Okay, so our u prime, that means we are differentiating u to cos to x. Our u prime is equal to 1, and our v1 is equal to integral of v dx, and that is integral of cos by nx over 4 dx. And when we integrate cos by nx over 4, we will apply our laws of integration. We would have sine by nx over 4 divided by n over 4. Now we can go further. This is our v1, and evaluate our v2. Okay, our v2 will be integral of v1 dx, and integrating v1 dx, we have it to be equal to integral of sine by nx over 4 over pi n over 4 dx, and this will give us minus cos by nx over 4 divided by n over 4. So understanding that this is equals to v2 and this is equal to v1, then we can now simplify an further. And we can simplify an further. So an will be equals to 1 over 2 minus 2 and we are integrating cos pi nx over 4, and integrating cos pi nx over 4, as we see here, will give us sine pi nx over 4 divided by pi n over 4 from a limit of minus 4 to minus 2. That means we are done with this part. Then let's proceed to the next part, where we have plus 1 over 4 and integrating x cos by nx over 4, we will apply u, okay, this is x, into v1, which is sine pi nx over 4 divided by pi n over 4 minus u prime is 1 multiplied by v2, this is v2 here, minus cos by nx over 4 divided by nx by n over 4 squared. from limit of minus 2 to 2, because we have here minus 2 to 2. And the last part that we are solving will be integral of this, which will give us 1 over 2 sine pi nx over 4 divided by pi n over 4 from the limits of 2 to 4, from the limit of 2 to 4. So having done this, we can now solve. It's looking a bit complicated, but let us slot in or simplify the brackets before we put our upper limit and lower limits. So an is equals to minus 1 over 2 of sine into pi nx over 4 divided by pi n over 4, limits from minus 4 to minus 2, plus 1 over 4 multiplied by x sine pi nx over 4 divided by pi n over 4, minus here and minus here will make it plus, plus cos pi nx over 4 divided by pi n over 4 squared from the limit of minus 2 to 2, and finally plus 1 over 2. Let's simplify this into sine pi nx over 4 divided by pi n over 4 from 2 to 4. Now let us now slot in our upper limit and lower limits. Putting in our upper limit and lower limit, we have that an is equals to minus 1 over 2. Let's put upper limit for this and lower limit. So we have sine. When we put in minus 2 here for x, okay, we end up having pi n minus 2 divided by 4. And this means that we will be having minus pi n over 2, or minus n pi over 2. So we're having minus n pi over 2 divided by pi n over 4 minus, if we slot in pi x to be minus 4, we would end up having sine into minus pi n 4 over 4. Okay, and this pi n 4 over 4 is the same thing as writing pi n minus pi n minus n pi, as the case may be. Okay, divided by pi n over 4. Now, to make it much more reliable, we can bring our n outside. So we have sine n, so it looks in the format that we are familiar with. So having done the upper limit and lower limit of this, we can now proceed and plug our upper limit and lower limit for this also. So we have it to be plus 1 over 4 upper limit of 2. So wherever we see x, we put 2, I'll give us 2 sine pi n2 over 4, and this can be written as sine n pi over 2 divided by pi n over 4 plus cos n pi over 2 by pi n over 4 squared minus the lower limit of minus 2. So we have minus 2 sine n minus pi over 2 divided by pi n over 4 plus cos n minus pi over 2 divided by pi n over 4 squared. Now we are done with plunging the upper limit of and lower limit of the second term here, and the third term we have it to be 1 over 2 upper limit of 4, we have sine n pi minus the lower limit of 2 divided by n pi over 2, and the lower limit of 2 we have it to be sine n pi over 2 divided by pi n over 4. So while we have this, we recall that sine n minus pi is equal to minus sine n pi. Okay, and sine n pi is equal to 0, and cos n pi over 2 is also equals to 0, and cos n minus pi over 2 is equals to cos n pi over 2 according to even function, which is equals to 0. However, sine n pi is also equals to 0, and sine n minus pi is equals to minus sine n pi, which is equals also to 0. So what we are left with is sine n into minus pi over 2, and sine n into minus pi over 2 is the same thing as minus sine n pi over 2. So in that case, let's nullify necessary terms. We have sine n minus pi here, and we can see sine n minus pi here equals to 0. So this term is equals to 0. Okay. Now we have also cos n pi over 2 here, and cos n pi over 2 is equals to 0. We have cos n minus pi over 2, and cos n minus pi over 2 is equal to 0. We have sine n pi, and sine n pi is equal to 0. Yeah. So at interim, we will be left with variables. 1 will be left with 2, and we'll be left 2 will be 3, and this is 4. So we are left with 4 times. So let's simplify those 4 times again. So we have an to be equal to minus 1 over 2, this being the first term that we're after, okay, into sine n minus pi over 2 over pi n over 4, and the second term is this 1 over 4 plus 1 over 4 into 2 sine n pi over 2 divided by pi n over 4. And then followed by this third term. Now that this minus here, cancel this, multiply this minus here, and be left with plus. Okay, so we'll be left with plus 2 sine n into minus pi over 2 over pi n over 4 squared. Sorry, pi n over 4 whole squared. And finally, the fourth term, we are left with plus 1 over 2 into minus sine n pi over 2 divided by pi n over 4. Now, when we solve this further, we recall that sine n minus pi over 2 is equals to minus sine